Yes, thank you, Katrin, and welcome to all attendees once more. I'm Jana, the Technical Product Manager of PointSense Heritage, and I'm glad to give you a brief introduction into the PointSense Heritage product. PointSense Heritage is also an AutoCAD plugin. What is PointSense Heritage meant for? It provides you tools if you are an archaeologist or working in historical preservation. It provides you tools which help you to create your typical deliverables such as image plans, layout plans, elevations, sections, and even 3D models for the documentation of historical buildings and archaeological excavations. Using laser scans, and in addition to the laser scans you can use photographs, and it's all inside AutoCAD. The features of PointSense Heritage are very similar to those of other PointSense products. The basic features are you can import point clouds, clip them, slice them to work with them further, and you can manage those slices. You can then use the point clouds in AutoCAD to model and analyze surfaces and volumes. I will show you in short. And you can also create ortho images of point clouds and true ortho photos. We'll have a look at this as well. And you can use PointSense Heritage for monoplotting. What monoplotting means will also be explained within a few minutes. Further, you can unwrap point clouds and photographs of objects in order to create image plans, very common in the heritage field of application. Besides this, you can also do some multiple image evaluation, which is classic photogrammetry. We come to that too in my presentation, and like all other PointSense products, PointSense Heritage also provides you a planar scan view, which might be of use if navigation in the point cloud gets too complicated and too less intuitive. Okay, let's start with the basic features you have in PointSense Heritage, like clipping point clouds. You can clip the point clouds in order to remove obstacles. You can crop areas of interest. You can define slices and sections to create profiles, layout plans, and elevations. Very similar to what you could see in PointSense Building if you joined the previous part of the webinar. You can colorize the point clouds in order to create, for instance, elevation maps of excavations, or to do deformation analysis of historical buildings, for instance. But you can also just define your own colors for areas in the point cloud you defined and color them by age dating or by the material in order to create thematical maps. You can then model and analyze surfaces and volumes. Therefore, PointSense Heritage provides you with pattern recognition tools. You can fit polygons and lines and then use those polygons and lines together with native AutoCAD commands for 3D modeling like loft or extrude. There's also a pattern recognition for cylinders in point clouds. You just have to click 2 points on the cylinder surface in order to create such a cylindrical column, for instance. And you can fit planes, which is very helpful to measure deviations from average planes, for instance. Let me give you a brief impression of the functionality I introduced so far. So I will jump into AutoCAD, where I have loaded a point cloud of a tower. It's the City Hall Tower of Dresden you see here, and I like to model the rooftop in 3D. To do so, I will just crop my area of interest, which is the rooftop up here. I'm just pressing enter to crop it, and I can name the section to roof, let's say, just in order to come back later to that section. For modeling this rooftop in 3D, I can use the AutoCAD Loft command, and this will need the profile polygons of that roof. And I can create them by defining single slices, but in this case we also have a feature for creating multiple slices. There is a wizard that guides you through the process. I will define the slices parallel to the XY plane of my user coordinate system, and I will define intervals at 1 meter. If I want to have a more precise model, I can of course choose shorter intervals, which is correct the range to round values or full meter values here, and then I created a station list. I could also add some special stations to the list, also from the CAD drawing, if I want to ensure that I have a slice at a certain area. Then I continue. I define the slice thickness and a basic name of all the slices. I can also add the consecutive number or station value to the slice name. I could color the slices, but in my case I don't have to. So I just say complete, and you see I have nice slices of the roof up here, which I can now use to create the profile lines with. And I just right click on a slice in the section manager and isolate it, and you can see here we have just one slice. And now I will use the fit polygon command. I have to switch to the top view to do the fitting, because the point cloud was quite huge. I zoomed out a bit far, but now I can just draw in approximate polygon. It needs to have the same number of vertices like the resulting polygon should have, but I can click very roughly and close this. Now I have done a mistake. Just repeat that. Okay, click it roughly. Close it, say finish, and the software is fitting the polygon to the slice. Then I just go to the next slice, run the command again. Now I can select objects. I can use the previous polygon as approximation and then just run the algorithm again, and proceeding like this I can create all the polylines. For you, I have already prepared some more profile lines of that roof. You can see them, and I can now use the loft command of AutoCAD in order to model the rooftop in 3D. Therefore, I have to select each polygon, profile polygon, come on, yeah. There are quite a few, but the loft command needs them in the correct order, so I have to click them one by one. Okay, just pressing enter and enter again. And then we have the rooftop. Let me just show you how it fits to the point cloud. Sorry. Okay, so this is how you can model 3D and how you can use pattern recognition algorithms and the slicing of PointSense Heritage to create 3D models. Let me jump back into the presentation to show you some more functionality of PointSense Heritage. There is a very new feature with a version 9 of PointSense Heritage, which will be released in beginning of June. This is meant for analyzing cylinder-shaped objects like this tower over here. You can use it to unwrap point clouds with the same deviation to the unwrapped plane like the points have to the average cylinder. Therefore you can easier use the cloud for analysis. You can color code the point cloud then by deviation. This tool also provides functionality to create reports and to export data to Excel or ASCII formats, and you can generate those cross-section polylines similar to what I've demonstrated with the tower. You can then automatically create solids from those cross-section polylines, and you can also calculate a deviation grid and insert it into the drawing. And you can use the tool to calculate volumes at different intervals. Let me show you with a small video how this feature is working. You see there we have a tower of a mosque, and again clipping tools are used to clip the area of interest, which is the more cylindrical part of the tower, and I then clip the point cloud again for cylinder fitting. This is an old command for cylinder fitting where I have to clip it to the cylindrical part. I will then stretch this cylinder to the top and also to the bottom of that more or less cylindrical part of the tower. And this is because I want to use this average cylinder for my deviation analysis and for my solid creation. So I selected the cylinder and I have to select a slitting point. Then in the dialog I have to define a maximum expected deviation, and also for the grid I have to define a grid width, which also applies then for the solid creation. So the denser the grid, the nicer the solid will fit to the actual point cloud. Also an unwrapped point cloud is created, so I have to define a name for that. And after a while, which we shortened for the video, you will have a solid fitted. You can see due to that I did not crop out very precisely. The solid was a bit rough. Here you can see the deviation grid that is inserted. I will add the unwrapped point cloud to the drawing as well. You can see the points have been added. Let me just switch off the grid for a while because it's too dense to see the point cloud behind it. And let me also crop out this part, this unwrapped part of the point cloud, in order then to show you how you can color code the deviations. I name the deviation part of the cloud here, and I use the elevation map to colorize this unwrapped point cloud with a minimum and a maximum elevation. I will just smooth the interval a little bit, and then you can see the colorized point cloud, colorized by deviations. So you can create a deviation report drawing by this workflow, and of course you can also insert a legend to show your customer the deviation values. Okay, let me jump back into my presentation to show you a few more features of PointSense Heritage. There are there's a possibility to create ortho images and true ortho photos. You can use them to plot high resolution point clouds and photographs in best quality. You can use the photographs in addition to the point cloud in order to get more dense image information. You can then use the ortho image as an image plan to draw in it and to add some annotations and dimensions. And everything which was parallel to the image plane is projected to scale in the ortho photo or ortho image. The monoplotting feature of PointSense Heritage is meant for drawing on high-resolution oriented photographs, and the 3D geometry will then generate it directly on the point cloud. I guess many users in archaeology do have regal scanners because you have longer distances to scan, and regal scanners do automatically also create oriented images, and this way you can combine the less dense point cloud with the high resolution image you've created. Let me just show you in a small video how this is done. You have the photograph in perspective view on the left hand side. This is really PointSense Heritage functionality, and you see on the right hand side how the 3D geometry develops right in the point cloud. Okay, this is how monoplotting does work. If you have taken more than just one oriented image and don't have very dense point cloud or don't have scanned at all, you can orient photographs which overlap and use classic photogrammetry for 3D modeling and also for creating facade plans, for instance, even without the laser scans. This works like shown in this video over here. We have the two images in perspective view, and I have to click on the left and on the right image, the corresponding points. You see the gray lines, which I can also refer to. These are the epipolar lines, which help me to digitize the edge of that feature. Okay, and another functionality in PointSense Heritage is the possibility to unwrap point clouds and photographs to create image plans. So you can unwrap point clouds of towers, walls, facades, ceiling frescoes, and much more into the plane, and then digitize and evaluate in detail on top of the resulting image. On the slide we have an example of the same tower which I used for the deviation feature demo, and the unwrapping functions like this. You fit a cylinder and then unwrap it to the plane, and then you can digitize in the planar image. Another possibility would be to, for a facade like this, you first, by slicing and fitting a polyline, you define this polyline and then create a so-called prismatic surface by selecting the polyline and then defining the upper extension of that projection surface and the lower boundary of the projection surface. Then you run the command for unwrapping the surface. You have to select the projection surface and then also a reference point in the cloud, and you have to define which maximum distance the points of the cloud can have from that projection plane. This way you are prevented from needing to crop the cloud too much before you can unwrap the cloud. Then you select the cloud for unwrapping and start the process, and you are asked to switch to the plan view. Here the unwrapped result is not very nice because we didn't have photographs in addition, and the point cloud was not very dense. And you can see that you can dimension with AutoCAD commands in the resulting image plan. Okay. Finally, I just want to remind you that also in PointSense Heritage we have the planar view, scan view feature with photo-like display of the scans where you can navigate more intuitively than inside point clouds. You do not have the risk to accidentally snap hidden points because it's a single scan based and you can only snap those points seen from that scan position, and the point cloud does not have to be loaded in AutoCAD if you use the planar view option of PointSense Heritage, which is provided with a special Vertiserve license, which is included in the PointSense Heritage package. Let me just demonstrate with a Heritage example how you can use the planar view of Vertiserve on the left hand side, and on the right hand side you see that already the layout had been drawn, and now you can just draw the arc of the church as well. So all these features together are inside the PointSense Heritage package, which helps you with flexible evaluation with a combination of laser scanning and photogrammetry in one package. PointSense Heritage adds multiple features to your familiar AutoCAD interface.